Yeah. Good evening, everyone. Joining us, let's start off. We'll be starting off with a new chapter today, Kinematics. And I do know PACE has a major test tomorrow, so most of you are preparing for it. I will try to wrap up by 10 o'clock, so we will just have a short class today so that you will have time for tomorrow's exam. Others, do keep your cams on.
I don't know why I'm not able to start this one. 1 second.
Do check it out, see what went wrong. Okay, let's start off. Kinematics, important chapter. So whatever we learned so far, calculus, vectors, everything will just pop up. So what is kinematics exactly? It's a study of motion. Without inquiring about the causes of the motion. So if I say a body is projected with 10 meter per second, we are not going to ask how did you get 10 meter per second. If I say a body is having an acceleration, we're not going to ask how did you get acceleration. Right? So we'll not be interested in how did you gain that velocity or what caused it. That we'll be doing in another chapter called laws of motion. That'll be the next chapter. So the important word is motion here. So how do you know something is moving? How do you know something is moving? Is Mount Everest moving? It depends. What if you're standing on the moon? Then Mount Everest is moving, right? So think like this. Let's say you and I are in a train, both are sitting, and there's a guy on the platform. So if you ask me, I will say you're at rest. If you ask the person on the platform, he'll say you're moving. Who is right?
Both are right.
Both are right. So depending on the frame of reference, right? Anyone can be right. Right? Anay, cams on, Saurja, cams on. So depending on the frame of reference, you can be moving, you can be at rest. So the most important thing in physics is always define your frame. So we define something called an inertial frame. What's an inertial frame? A reference frame about which observations are done. For convenience, we choose the Earth as a reference frame because most of the time we do all the problems in the Earth frame. But remember, we can actually choose any frame as reference. You can choose Sun as a reference frame. But once you choose a reference frame, make sure to solve all the problems with respect to that frame. Then we define something called a non-inertial frame. So any frame accelerating with respect to inertial frame if you have a vehicle accelerating on the earth, we will say it is a non-inertial frame. More about this we will discuss in more detail, in laws of motion. But one thing you should know, Newton's laws of motions are not valid Basically, the Newton's first law, second law, and the third law, they start failing in the non-inertial frame. So that is the reason it is important you need to define your frame properly. Am I in an inertial frame or non-inertial frame? But more about this, we will deal in the next chapter. But for now, have this much idea that whenever you start a problem, always be very clear where are you standing and observing the problem. Clear. So that is the whole story of this first page. Whenever you solve a problem, you have to be clear about which frame are you solving. If you take a different frame and you observe stuff, you will start getting wrong answers. Clear? Any doubts on this? Great. Can I turn the page? Anay, Saurja, Anshul, Eka, Rakshika, clear, no? Perfect. Next thing. How do you know an object is moving? If the coordinates are changing with respect to time, we say the body is said to be moving. Okay. So we will do only two things today. We'll keep the class short, like I said. Distance and displacement. That's it. We'll just play with these two things today. More about this we will do in the next class. So what is distance? Length of the path traveled by the body. Between your initial and the final position. Sorry. So whenever you're going from one point to another point, you can go from one point to another in infinite ways. So the most important thing, right? Whenever you ask what is the distance traveled, the first question should be which path are you taking? So depending on which path you're taking, you can have different distances. So path 1, path 2, path 3. Have a look at this. Any doubts on this page? Do check it out. Ali, clear, na? Anay, Maika, Pratyush, clear. So how do you calculate distance? Case 1, we have two formulas here, important ones. Listen carefully. Distance is nothing but speed into time. But what if the speed is not constant? So case 1, distance is given by integral mod v is speed dt. So here v bar is velocity, mod v bar is speed. So if you have a body whose speed is changing, you have to integrate. So when to use this formula? Use this formula if v is given in terms of time. We'll do some problems on this. There is a case 2. let's say we have a random path like this and you're trying to find the distance. So take a small piece here, ds. This is a small path on the curve. This is dx and this is dy. Since it is so small, you can treat it like a triangle. ds, dy, and dx. We can write ds will be equal to root over dx square plus dy square, Pythagoras theorem. You can take out dx common. You end up with root over 1 plus dy by dx whole square. And if you integrate, we will get distance will be integral ds. So what you're adding is, you're adding all these small arcs. You're getting what you're doing? You're adding these small pieces. When you add all these small pieces, what you get? You get the total length of that curve. So this becomes integral root over 1 plus dy by dx whole square into dx. You can also write this thing as integral root over 1 plus slope. dy by dx is nothing but slope square into dx. This is the second case. And when to use this? Use this if the equation of the curve is given. I think you can put down these two formulas, the ones in the red box. You can just note down that main formula there. That is how you can calculate distances, if speed is given in terms of time or if the path is given. Clear? Any doubts on this thing? It's important one. Generally neglected, like people, when it's a distance, they just calculate. But there are kind of problems you can ask. Siddharth, clear with this? Sarja, clear, na? Ekansh, Lakshika, Maika, Pratyush, Anshul. Anshul, do adjust your camera, I can't see you. Can I go to the next page? Anay? Great. Next thing is displacement. What is displacement? It is a vector joining the initial and the final point. So if you have 2 points here, let's call it A, which is AX, AY, AZ, and you're going to point B, which is BX, BY, and BZ. The displacement vector is from A to B bar. This vector will be OA bar. This vector will be OB bar. So we can write the displacement vector AB bar is nothing but OB bar minus OA bar. This is how you find displacement when positions are given. So this can be also written as Bx minus Ax. So B minus A, you're going from final minus initial plus By minus Ay j cap. So literally you're finding the vector AB bar. Bz minus Az k cap. in the form of integration, displacement is nothing but speed into time. So displacement will be integral v bar dt. You don't put the modulus. If you put modulus, it becomes speed and then it becomes distance. And the most important thing, meaning a formula here, relation between them, distance is always greater than or equal to displacement. Now be careful here. This is not right. Reason, this is not right. You know why? Why is this wrong? Anyone? Why is distance greater than equal to displacement wrong? Any ideas? You have to just put a mod, it becomes right. Because distance is a scalar and displacement is a vector quantity. You can't compare directly. What you're saying is distance is always greater than equal to magnitude of displacement. You can't compare a scalar and vector directly. It's like asking 2 and 3 I cap, which is greater. Doesn't make sense. You can always compare the magnitudes. Do check it out. This is how you find displacement. Clear? Ali, got this? All clear? Let's say a question. Let's say we have a cone, hollow cone. The radius is r and the slanting length is L. In this corner A, there is a small ant. Those who are in the basic foundation and the first demo class, we did something like this. Let's see if you remember this. So the ant goes from here, goes around the cone, and comes to this point here, B, where this is a B is the midpoint of that side. You're getting? So an ant walks on the surface of the cone from A to B in a shortest path. There are infinite ways you can go actually. Think about it. Can't you go like this? You could have gone like this. You could have gone like this. You could have gone like this. There are infinite ways you can go to B, isn't it? Among all of them, there's only one shortest path. Find the length of the shortest path. And B is the midpoint of the side. Let's call this point O is the tip, midpoint of OA. I hope the question was clear. How do you do this? So we have a hollow cone of radius R and the side slanting length L. The ant starts from one corner A, it goes around the outer surface and reaches B. It can go this in infinite ways. But there is only one path which is the shortest. Find the length of that shortest path. How do you approach this? Anyone didn't understand the question, please ask. Question is clear, please go ahead. You got 3 minutes. Any ideas? How do we do these kind of questions? I'll do one thing. Let me give a simpler version of this, and then let's get back to this question. So let's see the simpler version of this. Let's say we have a cube. Cube of side A. This is point A, and this is point B. B is the midpoint of this thing. Okay. There's a hollow cube. So same question, and walks from A to B in a shortest path. Find its length. How do you approach this problem? The concept behind this and the previous one is the same. I'll just call it B part. This would be an easier version of this. How do you approach this? Think for a minute. We got a cube. A is the corner and B is the midpoint of the top ka side. Find the, and the and goes from A to B in a shortest path. Find the length of it. How do you do this part? Think for a minute. I'll show you the cube. Then we'll go back to that cone again. Listen. 3a by 2 na re Pratyush. See, the problem, I'll tell you. What problem are you facing in solving this problem? The problem is, in school, we studied the shortest distance between 2 points is a straight line in a plane. In a plane. Problem here is when my ant is walking here, it is going in a 3-dimensional structure, and we are unable to visualize how the hell it is walking actually. So what is the problem here? The ant is not walking on a plane. So let's make it a plane. So what I would suggest, this cube which we have, like this, where this was point A and where this was point B, right? So this is the thing, no, perpendicular. So let's just push that wall onto the floor. Then the shape becomes like this. You get 2 squares where this is point A and this is point B. Does everyone agree with this? If you just open the cube and make it flat on the ground, what you'll see is 2 squares side by side. What is the shortest path? A straight line. Now fold the cube again. Isn't this how it looks? Is this making sense, everyone? If you open the cube and open it on a flat surface, it becomes on a paper flat surface. Draw the straight line from A to B and fold the cube again to the normal. And then this length would be 1. This is 1 and this is half. Use Pythagoras theorem. So AB will be root over 2 square plus half square. That would be root over 4 plus 1 by 4. That is root 17 by 2. Check. Is this making sense, everyone? Ekansh? Is this logic clear? Lakshika? Got this? Anay? Understood, right? Anshul? Sorja? Pratyush? Ali? Any doubts on this cube problem? Please ask. Siddharth, Mayuka, clear with this concept? So again, what is the concept? Whenever you have a 3D structure, we don't know what to do. So let's open the cube into a flat surface and then you solve the problem. You just draw a line from initial to final and you get the answer. Is this making sense? How do we do this thing then? So that means we have to open this cone into something, a flat surface, and then solve the problem. How do you open this? Try. I'll give you a minute or two, then I'll show you. How do we approach this? Ali, we can't see you. We are seeing something else in your camera. You're making some weapons. How do you open this code? Yeah. Listen, answer is not that good. So there we have a cone here, O, A, and B. So take a scissor and cut it here. And open this. You know what shape you get? A sector. Makes sense? When you open a cone, you get a sector. And if you observe this length, this green line, will be this line. Agreed? So what is the length of this green line? 2 pi r, the circumference. And what is this length here? L. L. So if you take this angle is theta, so L into theta is 2 pi r. That is how you can find the angle inside, 2 pi r by L. Now, let's look at the points. Where is A? A is here. Where is B? B is here, midpoint. What am I asking you to find? A line joining from A to B. You cut it along this line. So if you fold it back, what you get is a curve like this. Are you getting how it is? When you open this, it looks like a straight line, but when you fold it, it becomes a curve. So I'm asking you to find the length AB. How will you find length AB? This length is L by 2. That length is L. So I need to find AB and I know angle theta. Anyone? What to do from here? Did everyone understood how did I cut this? Anshul, are you clear with this? Lakshika, clear, no? Anay, the logic is clear. Sorja? Anyone not
So
clear,
we
not
need to
convinced,
message
please
the
ask.
answers on the host one or the co-host one.
Co-host, co-host,
Okay.
co-host. This thing. How to find AB length here, everyone? Anyone remembers this? I taught you this in trigonometry. Let this length be x. Cosine rule, everyone. Cos theta will be L square plus L by 2 whole square minus x square by 2 into L by 2. Cosine rule. In case you forgot the cosine rule, if this is angle A, this is B, and this is C. Cos A is given by B square plus C square minus A square by 2BC. This is the formula. So just shift everything here. This would be L square cos theta plus L square by 4 minus x square. So from here we get x is equal to 5L square by 4 root over 5L square by 4 minus L square cos theta. That's your answer. Numbers are given, you would have got it more easily, but yeah. So the concept one in this problem is we have to cut the cone and make it into a flat surface. When you do that, you get a sector. Then you take the initial point and the final point B and you just join them. So you get a straight line. So this straight line, when you fold it, it becomes a curve. Put it down. Do check it out. Any doubts on this, please ask. It's a good one. This would be a proper advanced level problem. And then we use cosine rule to find the AB. That's not a right angle triangle.
So if the length was 1, then the answer would be 5 root 5 upon 2 minus cos theta ka root, na?
5/4 minus cos theta ka root, yeah. All got this? Any doubts on this? Let's see something as more simpler version, which can be useful for your coming up exam. Can I turn the page? Any doubts on this page? Please have a look at this. Siddharth, clear now? Siddharth, there?
Yes, sir. Yes, sir.
Perfect. Next one. A particle is going along the x-axis. Whose x coordinate is given by x is equal to t cube by 3 minus 3t square by 2 plus 2t plus 1. Right? I'm going to put multiple questions on this. Like I said, it'll be a decent practice. You can cover a lot more in this. First one, find displacement in 2 seconds. Displacement and distance in 4 seconds. Time interval. This should be a proper advanced matrix matching or a paragraph. Time interval when particle is speeding up and speeding down. Speeding up means speed should increase, speeding down means speed should decrease. Speeding up or down. Let's get this. How do you approach this? X is given. That is only x coordinate. It is going on a single line. Any answers there? You can type in the co-host here. Displacement is easy. So exam what will happen? They'll ask you distance, but most people will find displacement. Both are not same. Here, luckily I gave both of them, so you'll get a doubt. Exam people don't even get a doubt. They ask distance, they'll find displacement. Whenever you hear the word distance, always be scared. It's a trap. Physics may, if they ask you to find distance, it is really messed up. Most of the time it is messed up. You always have to be very careful. Clear? Let me help you. See, the displacement is easy. So at t0, where are you? At t0, x is 1. Be careful, you're not starting from origin. At t is equal to 4, where are you? X is equal to 4 cubed by 3, that is 64 by 3, minus 3 by 2 into 4 square, that is 16, plus 8 plus 1. That would be 64 by 3 minus 24 plus 9. And this would be 19 by 3. So displacement is nothing but x final minus x initial. That would be 19 by 3 minus 1. That is 16 by 3 meters. This is the displacement. Check. Ali, check your calculations. So displacement is simply final coordinate minus initial coordinate. That's it. But distance is not that simple. Let's see how to do that. But take a minute and let's see. So most people will do this and they think they found distance. How do
Just
you
a second,
approach?
just a second.
Yeah. Right.
Sir, it's from t is equal to 0 to t is equal to 4, no?
4. Yeah.
Hmm.
Everyone should try. Got a minute. Lakshika, you got 17 by 3. You might be right. Do the B part. Time interval when it is speeding up and speeding down. I'll show you in a minute. See, displacement is 19. Displacement is 16 by 3, na, Akansh? You forgot to subtract the initial position. Now be careful. Huh? Whenever they ask you distance, first thing, differentiate this, you get velocity, which is t square minus 3t plus 2. If I equate this is equal to 0, you get t is equal to 1 in 2 seconds. Now listen everyone carefully. What is the meaning of this? The body is stopping 2 times. Means, you know, what is happening? At t0, where are you? At x is equal to 1. And you went forward. At t is equal to 1, where are you? Substitute. At t is equal to 1, x is equal to 1 by 3 minus 3 by 2 plus 2 plus 1. That is 1 by 3 minus plus 3 by 2. That is 11 by 6. That t is equal to 1, you're at 11 by 6. And then what happened? Where are you at t is equal to 2? X is equal to 2 cubed by 3 minus 6 plus 4 plus 1. You're at 5 by 3. The body has taken a turn. And you have come here. And again, it has taken a turn. This is how the body is going. Actually, it is going on a straight line. For you to understand, I'm showing you the curves. At t is equal to 2 seconds, again you take a turn. And you're at x is equal to 5 by 3. At t is equal to 4, just now we calculated, you're at x is equal to 19 by 3. Are you getting the difference? When you did initial minus final, you found this was displacement. But what was distance? Distance is this, and this, the total length. You have to add the distances while going front and coming back also. So distance will be this part, and this part. So distance will be 11 by 6 minus 1 plus 11 by 6 minus 5 by 3 plus 19 by 3 minus 5 by 3. And add them all. This would be 5 by 6 plus 1 by 6 plus 14 by 3. This is 1 plus 14 by 3. That would be 17 by 3 meters is the distance. Displacement is 16 by 3. Remember, this is the process for finding distance. There is no way out. You literally have to find the points where it stops. So whenever it stops, it's a turning point. It is going back for some time, then again it is turning here. So here it stopped 2 times. So it went forward, stopped at 1 second, came back, stopped at 2 seconds, again came, then went front. So you literally have to draw the diagram, and then you have to divide into pieces and add each piece ka length. Please look at the whole problem. It's a pretty good one. There's no other way to do this for distance.
So one question. So can't we use a formula that
Which formula?
integration speed dt?
But this is in 1 dimension, right? Kya karoge? That formula is mod v bar, right? This is just a 1 dimension. You can use that, but then you just have to make it a modulus of speed ka differential. It will be very difficult to solve. It will be more max question then. You're getting, Ali? Meaning in the function, you have to find out when it becomes negative and have to make it positive. Integration meant you won't be able to figure out here what is happening. Please check how we did this. It's a good one. Lakshika, got this? Sorja, Anai? Anyone not clear with this? Please ask. Question is still not over. Time interval in the particle is speeding up and speeding down. How do you find that? Speeding up and speeding down means speed should increase and speed should decrease. Try. I'll give you 2 minutes. First, you need to understand the meaning of speeding up and speeding down. Okay. Speeding up T1 to 3 by 2 and T greater than 2. Lakshika. So first, let's understand what is speeding up and speeding down. Most people have this misconception. Acceleration is positive to speeding up. Acceleration negative to speeding down. You are forgetting something. If A and V are in the same direction, so if you see here, A is positive. If A and V are in the same direction, the speed is increasing. It is speeding up. Suppose if A is backward and V is also backward, in this case, if you see A is negative, but still it is speeding up. So A positive and negative, right? It simply indicates a direction that has nothing to do with speeding up and speeding down. So when you get speeding down, if A is forward and B is backward, or if A is backward and B is backward, in this case, A is positive, and in this case, A is negative, but both are speeding down. That's the meaning of speeding up and speeding down. If A and B are on the opposite direction, we say the speed is decreasing. A and B in the same direction, we say speed is increasing. You can write it in a better form in 2 dimension or in a vector form. if the velocity vector and the acceleration vector, the angle is theta is acute, means the speed is increasing. The acceleration is actually increasing the speed. That is, a bar dot v bar is greater than 0. We say it is speeding up. Be careful, and this will be a proper multiple choice question in advance. Which of the following is the condition for speeding up? The reason, if you look at this component a cos theta will increase the speed. Suppose velocity and acceleration is like this. A cos theta will decrease the speed. In this case, theta is obtuse. That is, acceleration dot velocity is less than 0. This is speeding down. In vector form, this is the much more powerful than this thing. In 1D, this works, but in vector form 2D, you want to find speeding up and speeding down. This is the condition. If the angle between the acceleration velocity vector is acute, meaning the component of acceleration is increasing the speed. If it is obtuse, the component of acceleration is decreasing the speed. Please check it out the vector form. Clear? So how do we solve this then? Ali, clear, no? This page, everyone? Sarja, clear with this? Anshul, Ekansh, I hope clear with the speeding up and speeding down part. So we have x is equal to t cube by 3 minus 3t square by 2 plus 2t plus 1. The velocity will be t square minus 3t plus 2. You can write this thing as t minus 1 into t minus 2. And if you look at this function, if t is less than 1, v is negative. If t is between 2 to 1, v is positive. Because t minus 1 will be negative, t minus 2 will be negative. If the time is between 1 to 2, v is negative. For t greater than 2, v is positive. Similarly, if you look at the acceleration, which will be 2t minus 3, for t greater than less than 3 by 2, acceleration is negative. For t greater than 3 by 2, acceleration is positive. Just little math, do check it out. So, for time less than 1 to 0, v is positive, a is negative. Means it is speeding down. Since both are opposite. You literally have to check for each time interval. For t between 3 by 2 to 1, v is negative, a is also negative. So speed is increasing. This is the reason I said it's a proper, advanced multiple choice question, matrix question. For t less than 2 to 3 by 2, v becomes positive, no, v is still negative, but a becomes positive. This is speeding down. For t greater than 2, v is positive, a is also positive. Speeding up. So the answer is 1 to 3 by 2 and t greater than 2. Please check this thing. So if they ask you to find speeding up and speeding down, this is how you do. Find the velocity, find the acceleration, find the time intervals when it is positive and negative, and then you compare in which region both are positive and which region both are negative. Do have a look at this. Clear? Anyone not convinced with this? Anything you're not clear, please ask. It's a pretty good question. It's actually 2-3 questions I combined into one. Clear, everyone? Anay, clear, na? Ekansh? Pratyush? Rakshika, you got this right. But the vector form was something different. Clear? Ali, can I go ahead? Sarja, clear, na? Perfect. A particle moves along the curve y is equal to root over 4 minus x square. From 2, 0 to root 3, 1. Find the distance traveled. Now, which formula to use? Whenever the equation of the curve is given, you have to use the case 2. Remember? This is the formula you have to use, case 2. If the I hope everyone has written that formula there. In case you're not written, you can just put it down. Integral root 1 plus dy by dx whole square dx. Whenever they say you're going on this particular path, you have to use this. Let's get this. Let's finish it off. We'll wrap up with this. I know you guys have an exam tomorrow. Some of you are tensed. Let's finish off with this. A little introduction of kinematics we did. So on Monday onwards, we'll continue again with full force. Finish up. Last one for the day. Meaning, for people who don't know the context, half of that batch, right, is from classes in Mumbai called PACE. And these people have something called a major test tomorrow. And most of them, I'm sure they didn't read chemistry ka periodic table and sab by heart nahi kiya abhi tak. That is one thing everyone plans to read exactly one day before. So let's finish up. We'll wind up with this. This is the formula. Try. First thing, differentiate that. So dy by dx would be half root over 4 minus x square into differential that minus 2x. We get minus x by root over 4 minus x square. Substitute inside. So integral root over 1 plus x square by 4 minus x square dx. Multiply, you end up with x by 2 by root over 4 minus x square dx. And what are the limits? You're going from x initial to x final. X initial is 2, x final is root 3. And in case you forgot, dx by root over a square minus x square. This formula, last time we did an integration by substitution. This is sine inverse x by a. You can refer in calculus. There, this is the page. Dx by a minus x square. Last class we did this. Integration by substitution, page 145. You have the notes last class. In case you don't have, let me know, I'll send it again. Page 145 calculus. So this becomes 2. I'll show it in the next page, but do have a look at till here. So if you integrate this, integral dx by root over 2 square minus x square. So a ka place mein we have 2. Limits will go from 2 to root 3. So this will be 2 sine inverse x by a is 2. Limits are from 2 to root 3. You can put a mod because you want distance. 2 mod, substitute there, sine inverse root 3 by 2 minus sine inverse 2 by 2. Sine inverse root 3 by meaning it is pi by 3, 60 degrees, and 1 is pi by 2. So that will be 2 into pi by 6 or pi by 3 meters. Check. That's the answer, pi by 3 meters. So if they give you an equation
So
for
last
curve,
step,
and
what
they
you
ask
did, I couldn't understand.
yeah,
Last
this
step,
thing,
what you did, you find, I forgot.
this
By
one,
yes.
sine theta 3 by 2, na? Theta is what then? 60 degrees, na? Sine 60. And sine inverse 1 is what? 90, na? Right, Ali? Yeah. So sine 60 would be root 3 by 2 and sine 90 would be 1. So we did that. Do have a look at the steps, everyone. This is an important model there. Check. All clear with this? Soja, clear? Anay? Anshul? Maika? Pratyush? Rakshika, clear, na? Siddharth?